The topic that I will be discussing today is double integration. Double integration is actually the extension of ordinary definite integral. In ordinary definite integral, the integrand is a function of one variable, whereas in double integration, the integrand is a function of two variables. The double integration has a lot of application. It has the application in finding out area, mass, volume, etc. So let us consider here f of xy is a function of two variables x and y. Here R denotes the region of integration. The first example that we take over here is the one in which the limits of integration are known. So looking at the first integral, we see that one of the limits has the variable y. The first step is to decide the order of integration. So if in the integral we find that the limit has y as one of the variables there, then the order of integration will be first with respect to x and then with respect to y. So here in the first bracket we carry out the integration with respect to x. Now looking at the integrand, we see that this integral can be solved by using the integration formula of root of a square minus x square. So the answer for this, the result will be x upon 2 root of a square minus x square plus a square upon 2. So here it is the constant term square, which is a square minus y square by 2 sine inverse x upon the constant term, which is root of a square minus y square. The limits of integration are 0 to root of a square minus y square. So here we put the upper limit first. That is, we replace x by root of a square minus y square. Here also x square is replaced and we get this result. And plus a square minus y square by 2 sine inverse. Again here we replace x by root of a square minus y square. After that, to put the lower limit, we first put minus sign and replace x by 0. So we get here 0 by 2. Here also we put 0 and plus a square minus y square by 2 sine inverse 0. On simplification, we find that this term is 0. So we are left with a square minus y square by 2 sine inverse. Here we get 1. So we get sine inverse 1. And the lower limit is giving us 0 answer. So now we replace the value of sine inverse 1 as pi by 2. We take the constant terms outside. So we take pi by 4 outside and now the integration is done with respect to y. So the integration of a square is a square y and the integration of y square is y cube by 3. Again we put the upper limit and lower limit. So we replace y by a, which is the upper limit. So that we get a cube minus a cube by 3. And then after minus sign we put the lower limit, that is we replace y by 0. So which gives us 0 answer. Now on simplification, the final answer is pi by 6 a cube. Now we take up one more example where the limits of integration are not given, but region of integration is given to us. Region of integration here is x plus y less than or equal to 1 in positive quadrant. So here first of all we have to plot x plus y less than or equal to 1. So first in this equation x plus y less than or equal to 1, if we put x is equal to 0, we get y is equal to 1. And if we put y is equal to 0, we get x is equal to 1. So let us plot these points. When x is 1, y is 0, and when x is 0, y is 1. So if we join them, we get a straight line, and this is the line x plus y is equal to 1. This line can also be written as y is equal to 1 minus x. Here this is x-axis, and equation of x-axis is y is equal to 0. Now the region of integration is given as x plus y less than or equal to 1 in positive quadrant. Positive quadrant means first quadrant, and x plus y less than or equal to 1. So the region of integration is actually the triangular part. Now in this question, since the limits of integration are not given, so we have to decide the limits. So we first of all decide whether to integrate with respect to y first or with respect to x. If we want to integrate with respect to y first, then in this region of integration, we have to consider a vertical strip. Let this strip be AB. So the location of point A gives us the lower limit for y, and the point B where it lies, the equation of that line gives us the upper limit. So if we look at point A, the equation of this line x-axis is y is equal to 0. So limits of y are y is equal to 0 to y is equal to upper limit. So we look at this, that point B lies on the line x plus y is equal to 1, but in terms of y it can be written as y is equal to 1 minus x. So the upper limit is y is equal to 1 minus x. Now to get the limits of x, this vertical strip is moved from left to right in the triangular region so that it covers the entire area. And the limits of x are given by the minimum and maximum value of x in the region. So if we see, then the minimum value of x here is 0 and maximum value of x here is 1. So limits of x are x is equal to 0 to x is equal to 1. So now the double integral can be calculated as x is 0 to 1, and then here we have y is equal to 0 to y is equal to 1 minus x, and we have to do the integration of xy. So first we are integrating with respect to y, and that is why x being a constant we keep it outside, and here we integrate with respect to y, and then whatever the result comes in, that we have to integrate with respect to x. So what we get here is second integral will be as it is x and integration of y, which is y square by 2. Limits are 0 to 1 minus x, and afterwards the integration will be with respect to x. So simplifying, we get x upon 2, which is a constant we are keeping outside. Y is replaced by 1 minus x. Upper limit minus the lower limit. So we get the answer as 1 by 2, which is a constant, is outside x, and 1 minus x whole square we have to do. So 1 minus 2x plus x square, integration with respect to x. So this is equal to 1 by 2 integral 0 to 1. We take the product x minus 2x square plus x cube dx. So we integrate each term here with respect to x. So what we get is x square by 2 minus 2 x cube by 3 plus x fourth by 4. And limits are 0 to 1. So we substitute the value here. So the integration gives us 1 by 2 minus 2 by 3 plus 1 by 4. Simplify. simplifying the bracket and multiplying, the final answer that we get is 1 by 24.